Show that the function defined by g of x, which is equal to x minus floor function of x, is discontinuous at all integral points. So one more name for floor function is greatest integer less than or equal to x. So I would like to start off the answer with analyzing by giving it some input. So let's take 1.9. So this is 1.9 purely, it's nothing, but here it is floor of 1.9. First of all, how does a floor function look like and what is the floor of 1.9? This is your floor function. So whatever input I give, the floor function looks for the nearest integer values. Whichever is the lowest, it will pick that up. Between -1 and 1, the lowest is -1. So it will pick -1. So in my question, I have an input of 1.9. In this case, even though we have 2 to be the nearest value, okay, 2 to be the nearest integer value, but 1 is also the next nearest integer value. Between them, the lowest is 1, so the output is 1. So it does not matter, it is closer to 2, but still the output is 1. And overall the result is 0.9. Next, g of minus 2.3. This is minus 2.3 and floor of minus 2.3. Before this, I would like to show you guys the overall graph of g of x. Right, x minus floor of x is your graph, as you can see. So that's what I've defined over here. Now I'll run the code and this is your graph. If I give an input of 1.9, so it's somewhere over here. So you can see an approximate value, it is 0.9 itself. Right, so the answer over here is 0.9, that's correct. Now, what is the floor of minus 2.3? So first thing is, we have to look for where is 2.3. Okay, it's between -3 and -2. The lowest integer is -3, so my output is minus 2.3, right? Even though it's near to -2, my output is -3 itself. Okay, please understand this, because if you understand this, then the answer makes sense. If not, it won't make sense. So this is clearly 0.7. Now let me give an integer value like 2. If I have 2, obviously I don't have to show you guys this. My output is 2 itself, and so we have this to be 0. Right? So let me show this also. Actually, minus 2.3 will be over here. So minus 2.3, you can see answer is 0.7. Now I am giving an input of, say, some integer value like 2. Right? 2 is over here. I can see that the output is 0. You give any integer value, the output is 0. Right? Because floor function of any integer value is the same value. -3, floor function of -3 is -3 itself. So -3 minus of -3, this will be +3, and so the output is 0. And now we can start off with the answer. We'll consider n that belongs to an integer. It's a part of integer. F of n. If I give any integer value, as you can see, the floor of n will give us n itself, and so this answer is 0. This is very clear. The question is, we have to prove that it's discontinuous. Which direction should I approach? For example, if I have, say, 1, if I approach from the right hand side, my answer is almost equal to 0 itself, because at 1, remember, at 1, if I give an input of 1, we just saw that, yeah, my output is 0. If I approach from the right hand side, you can see approximately the output is 0 as well. Remember, this is approximation. Approximation takes us to 1.0009 or 1, whatever it might be. So it's very close to 1. While on the left hand side, as and when I approach to 1, my answer is something else altogether, right? It's not 0, my output is 0.98. So if I approach 0 over here, as you can see, my answer is 0, and at 0 output is 0. While I approach from the left hand side, my output is 0.96. Clearly approaching from the left hand side will give us an answer that it is discontinuous, and we are done. So let me explain it this way. We have limit f of x as x tends towards the negative from the left hand side of n. So let's write the floor function and the given set of expression, that's your function. Now on applying the limit, I'll get n minus floor of n from the left hand side. So floor of n from the left hand side will be n minus 1. And so this will result in n plus n minus, this is plus 1 and this is minus n. And overall picture is that this is equal to 1, which is not the same as f of n. Again, remember, we are looking at a value which is something like this. Okay, so let me make it clear. If I have, say, 2, right, approaching 2 from the left hand side. So approximately this is 2, and this is, when I'm approaching from the left hand side, it is 1.9999. For floor function, it is important with these values, because left hand approach will give us a different answer, right hand approach will give us a different answer. So this is 2 minus of 1. This will be 1. Okay, because 1.999 overall, the answer is 2 minus 1, that is 1, right? So this will be 2 minus 1. Okay, because floor of this will be equal to 1. So this is 2 minus 1 and the overall result is 1. Please understand this. If I give a floor function an input of 1.999, it will result in 1 itself. And so we have the following answer. And this infers that f is discontinuous clearly at all the integral values or integral parts, at all integral points. And we have the proof. So this is the most important point. If you guys understand this, then you have understood the question and the answer and the behavior of floor function. Again, people get confused with floor function. Understand it in deep manner, because in your exam, that's how you guys get confused. MCQ questions and all of that. It's an easy MCQ question and easy to trick you guys. So it's important for you guys to understand floor function in a very detailed manner.